Hello guys, welcome to another video of Velvi. So first of all, I would like to just apologize because I couldn't record videos for the past 1 month because I didn't have the facility to record. But I just moved to California and everything looks good here. So hopefully I won't be skipping a session from now on. In the past weeks, we saw about strings, lists, tuples, dictionaries, and today the topic that we're going to cover is sets. So according to Python documentation, a set is just an unordered collection of elements with no duplicate entries. So the basic uses include just membership testing and removing duplicate items. Okay, so let's dive into sets, see a few examples, and have a better understanding of what it is. Okay, so here's an example of a set A equal 1, 2, 3, 4. So as you could see, like sets are a sequence of items enclosed in curly braces. So when you see curly braces, you could think of dictionaries as well. But remember, dictionary had the key value relationship, right? So it was enclosed in curly braces, but it had something of this kind, right? So sets don't have that. Okay, so if you see something of this particular nature, it's always going to be of type dictionary. If you don't see of something like that, then it's just a set. Okay, so this is an example of a simple set with no duplicate entries being inputted. So you could see like 1, 2, 3, 4. Now we could just test its type using the type function, and you could see like it's just a set. Now let's say, for example, if I input duplicate entries to the set, let's see what happens. So here I create a set with elements 1, 2, 3 and 1, 2, 3. So according to the definition, Python should remove the duplicate entries and should give us only distinct items, right? So you could exactly see Python does that. So we just have like 1, 2, 3 instead of 1, 2, 3, 1, 2, 3. Okay, so it's quite simple. It's so far so good, right? We just saw examples of few sets. Also, you could just think of like, let's say, for example, if someone comes and asks you like, what books have you read or what books did you have in your library? You say like Harry Potter, Lord of Rings, the Bible, and so on. Let's say, for example, if you have like two or more Harry Potter books, you don't say like, I have Harry Potter, Harry Potter, Harry Potter, the Lord of Rings, and the Bible, right? So you just state only the distinct items, right? So sets is just of the same nature. So now we have seen in the past how to create empty dictionary, empty list, tuples, and so on. So similarly, to create an empty set, this is the way that you need to follow. Set is the keyword, and you just do this. So set of this is going to give us an empty set. Okay, so the way to find out pythonically whether this is empty or not, you could just convert this to a boolean. Okay, if the boolean turns out to be false, then it's empty, right? So let's see if it gives us false or not, and you could see it gives us false. So that means variable c is empty. So variable c is of type set, so this is an empty set. Okay, so simple. So in the past, like while creating an empty list, we saw f equal to just a simple square bracket gives us an empty list, but this isn't the case with sets. Okay, so remember the curly braces are being shared by both dictionaries and sets. So if you do something of this particular nature, it is not going to be an empty set, it's going to be an empty dictionary. Okay, so it's of course empty, but let's see its type. So you see it's of type date, so that's dictionary, right? So you can't create an empty set just by the curly braces, empty curly braces. Okay, so make sure you don't confuse the curly braces of sets with dictionaries. You will get it through practice. Okay, as you keep on practicing, you will have a clear understanding between the differences. So let's go ahead and see a few more interesting ways to create sets. So here we just saw like if you don't input anything, it's just going to create an empty set, right? So similarly, let's say if I input something, it's going to create a non-empty set. Okay, so here I just do like set of apple. Now the items that we have in the sets are A, E, L, P. So quite simple, right? You could see like in Apple we have two P's, but in the final output of the set E we just have one P. This is again because sets doesn't allow duplicate entries, right? So simple. This is another way that you could create sets from strings. Okay. So other ways like you just create sets from tuples, lists, and dictionaries as well. So I just have an example for each one of them here. So you could see like a set of a list. Okay, so in this list you could see like there are two apples, one orange, and two mango. Okay, so the final set should have like apple, orange, and mango. Okay, that's exactly what we have: apple, mango, and orange. So you could see again the duplicate items have been removed by Python. So similarly, you could do the same thing using tuples as well. So input a tuple to the set function and you get the same thing like output with no duplicate entry. So here you have green being repeated twice. In the final output, you just have green once. So similarly, when you input a dictionary, it's an interesting case. Okay, so dictionary itself cannot have like duplicate keys, right? So Python, when you input a dictionary to a set function, it's just going to consider the keys alone, not the value. So here you could see like I have a dictionary with the key apple, value red, key pine, value brown, okay, key lemon, and value as yellow. And then in the final output, we just see like apple, lemon, and pine. Okay, so Python really doesn't care about the values. It primarily cares about the keys when you input a dictionary to a set. Okay, so another important point that really want to make about sets is sets are mutable objects. That means they are subjected to change. Okay, just like we saw lists and dictionaries, how mutable they are. Like when you assign a variable, when you assign a set to a variable or a list to a variable, and you make changes in that particular variable, it is going to affect the other variable. We just saw these kind of things in lists, right? So all those things are applicable to sets and as well as dictionaries. Okay, I just want to make that particular point as well. So going ahead, now let's see a few operations that are related to sets. Okay, so here I create two sets. Set A is apple, so it's just gonna have like A P L E, and then set orange. So it seems you don't have any duplicate items in orange, so you have uh, all the items in the set. Okay, so let's just see few operations. So A minus B is just gonna give like the all the letters in A but not in B. Okay, so let's go ahead and do this. And okay, so we see like we have the output as L and P when we do this. So this is because we need to have the items that are in A but not in B, right? So in A we have items such as A, E, L, P. Okay, so let's see whether if any of these items appears in the set B as well. You could see like A appears in B as well. So that means like in the final output we are not going to have A. Similarly, E appears in B as well. So that means again E is not going to be in the final output. L doesn't seem to be in the other set, so as with P. So this gives us the final output L and P. Okay, so hopefully it's clear. So if we do the other way, B minus A, so this is going to give us letters in B, but the characters in D, but the character shouldn't be in A. Okay, so here you could see like A, E, G, N, O, R. So in this you could see like A and E appear in the set A as well. So this leaves us with the output G, N, O, R. Okay, quite simple, right? So this is one of the interesting operations. So the difference of two sets. Okay, so other operations are union. So union is just like kind of like put together all the two sets that we have. Okay, so here you could see like A E L P A E G N O R. So if we put all these items in a single set, So then we are going to have like AELP, AEGNOR, but set can't have duplicate items. So that leaves us with AELPGNOR, right? So that gives us AEGLNO and PR. Okay, quite simple. So this is how you take the union of two sets, and then intersection of two sets is going to give us the output of items that are present in both the sets. Okay, so here in A and B, you could see like the items A, E are the only two characters that are common to both sets. So that's why you have these two things in the output. And then like A caret symbol B is the symmetric difference. Okay, so this is going to give us the letters that are in A and B, but not in both. Okay, so what it means is it's gonna kind of like take all the elements of these two sets, but the final set shouldn't have the items or characters that are present in both the sets. So here AE is present in both sets, so that means like except AE we are gonna have all of the items in our final output. So you could see like GLNOPR is present. Okay, so we don't have AE in the symmetric difference that we take here. This is because A and E are present in both the sets. Okay, similarly, you could do the length of a set, ln of A. It's just going to give 4 because A has 4 items in it. Okay, hopefully it's clear so far. Oops. Yeah, okay. So let me quickly remove this. Actually, I had to have a different. Okay, so next what we are going to see is the set methods. So similar in when we saw about list or dictionary tuples, we saw several methods. So similar to list or tuples, sets also has several methods with them, and let's see one by one. So the first method that I want to introduce is the add method. So add is just kind of like adding a new item to the set. So simple, right? So let's say we have a set AELP, and if I just do like a dot add of z, so it's just gonna add the new item z to this particular list, sorry, this particular set A. So you could see like AELPZ. So you could see like when I did a dot add of z, I didn't assign it to a variable because sets are mutable, just like how we did for lists or dictionary. Okay, you need not assign it to a new variable. Okay, again, this is because of the mutable property. So make sure you have a firm understanding of the mutable and immutability. Okay, so I have explained this in detail in the previous videos. Make sure like you have a firm understanding. I just keep on repeating that because it's really important. Okay, so the other thing that I want to say is the difference method. So difference method is just like a minus b, just we saw above right here. Okay, so it's just going to give us the same output. So oops, so let me quickly do this. Since we are gonna update sets each time, so I don't wanna lose it. Okay, so A, B, so these are sets you have, and then like if I just do like A minus B, I have like LP, just as explained above. So A dot difference of B just gives us the same output, so literally these two things are same. And then there's another method called difference underscore update. So what it does is instead of giving us a new set like this, it's just gonna update the output that we generate to this particular set A. So let's see. So before doing this, let me quickly show what we have in A. So we have like AELP, right? So once I execute this thing, you could see like we have like LP because this particular thing automatically updates the set A to the output value. So that's the difference between A dot difference and A dot difference underscore update. Okay, so it depends on your program or on your situation whether to use just the difference or difference update. Okay, so it's purely dependent on your program or what you want to achieve at the time. So the other method that we have is discard. So discard is a method that removes an item from the set. Okay, so let's say we have these things here, and then we have a set AELP. If let's say if I want to remove the character A, I just do like A dot discard of A, and you could see like we just have ELP. Okay, so now let's say for example, if I want to remove Z, so you could see like Python really didn't throw me an error because it tried to remove the item Z, but since Z isn't in that particular set, so Python just returned the set as it is. So that's what we have right here. Okay, so with respect to discard, the item that you're trying to remove need not be a member of that particular set. So Python doesn't throw an error even if it's not a member. So the next method is intersection. So intersection is just like A and B. It's just going to return the items that are present in both both the sets. So you have this, you could see like A and B gives us AE. So A dot intersection B again going to give AE, just exactly the same. So and then intersection underscore update is just the same as like difference underscore update. The output that Python generates is going to be stored in this particular variable A. So you can see like now A has this values of A and E alone. Okay, so going ahead, disjoint. So disjoint is a method to check whether two sets are completely different or from each other. Okay, so let's say for example we have a set apple. Okay, so APLE and set orange, so that's ORANGE. If I want to check whether these two form a disjoint, so it doesn't form a disjoint because there is some overlap between these two sets. For example, A is something that is present in both these sets, and then E is something that is present in both these sets. So Python returns false. So I check are these two things disjoint, so false. So let's say for example if I create other two sets like A comma E and set D which has the value Z comma X. Okay, so if I execute this, Python is going to return true because there is no overlap of items or elements between these two sets. Okay, so the other method is subset. So this just checks whether a given set is a subset of the other set. Okay, so again I just have two sets A, B, and I'm just checking like A dot is subset of B. In this case it's false because let's say P, okay, P isn't available in the set B, so that doesn't make A as a subset of B, right? So Python returns false. So let's say for example in order to show you a subset what a subset is, so I'm creating a new set which has an items of E and G. Okay, so you could see like E and G, these two are subsets of B because they both are present in this set B as well, right? So Python is now going to return true in this particular case. So similarly to subset, you could just test whether a given particular set is a superset of another set. So let's just take the sets from the above example A, B, C. We just have these values in place. Okay, so I'm just checking whether A is a superset of B. It's not because you could see like uh, let's say G. Okay, G isn't present in A, so that doesn't make B a subset of A. Henceforth, A isn't a superset of B, right? So in the previous example, above we saw like C is a subset of B, so that makes B a superset of C, right? So if I just execute this, it's just going to return true. I think it's quite simple, right? So if you have any questions, do mention it in the comments, or if you have any feedback, so feel free to email me or leave it in the comment section as well. So going ahead, like pop. So the pop is just another simple method that kind of like randomly removes an item from the set. So you have like set orange, and then I just do b dot pop. Okay, just remove this element. Okay, quite simple. So you could even see the doc string for each method that we try to do. So if I just try to keep it here and press shift tab, okay, you could see like the doc string reads as remove unwritten an arbitrary set element, or I says key error if the set is empty. Okay, so it's just another simple example of a method. And then remove is just kind of like same as the discard method that we saw above. But the thing about remove is the element that you're trying to remove must be a member of the set. Okay, so here I'm trying to remove O, which is a member of this particular set. Let's say, for example, if I try to remove Z, Python is going to throw an error, key error, because Z isn't a member of this particular set B. So this is the difference between discard and remove. If I had used discard here, Python wouldn't have thrown an error. Okay, but with remove, the item that you are trying to take it out should be a member, should be definitely a member of that particular set. Okay, so this is the difference between these two methods, and the usage entirely again depends upon the program that you are trying to run. Okay, and then finally we come to symmetric difference. So it's just kind of like what we saw, a caret b. Okay, so it's just going to give us the elements that are present in both, that are not present in both the sets. Okay, so here we have like these two sets, and you could see like if I take the symmetric difference between A and B, we have like GLNOPR. So the items A and E are common to these two sets, right? A and B. So that's the reason why when you take a symmetric difference, you don't see the items A and E present in the output here. So that's what a symmetric difference really means. So finally, similar to the intersection and difference we saw above, we have like symmetric difference update as well. So the output that's being generated is going to be stored in this variable A instead of creating a new set. Okay, so finally you have A as this. So those were the few methods about lists, sorry, about sets, and there are a few more like clear, copy, and then like union and update, which is just kind of like very simple. I just want you guys to go through over those methods as well and to have a firm understanding about sets. Okay, so now we covered like most of the data structures. There are a few more like frozen sets, numpy arrays, which we will see later. But these are the basic data structures that you should definitely know in Python. So next week I'll just try to uh, do a video on the differences between tuples, lists, dictionaries, and sets, like its speed, like how much time it take, or like give you some use cases of when to use what, so that you have a good understanding of that. Or I'll just plan according to that, because we need to see like a condition statement, for loops, and so many other stuffs as well. So I'll just come up with a better plan so as to make sure which makes more sense to us. Okay. So if you have any questions, as I said before, feel free to comment below or email me so that I could help you out in all possible ways that I could. Okay. So thank you guys. So let's see next week with a new video at Velvi. Goodbye.